video, we talked about what line of sight, angle of elevation and angle of depression mean. The line of sight is nothing but the line drawn from the eye to the distant object. So when a person is looking at the top of this tower, the line of sight is this. And when the person is looking at the bottom or the base of the tower, the line of sight will be this. The angle of elevation of the point being viewed is the angle between the line of sight and horizontal when the line of sight is above the horizontal. We see here that the top of the tower is above this horizontal drawn. Hence this angle, say θ1, is the angle of elevation. The angle of depression of the point being viewed is the angle between the line of sight and the horizontal when the line of sight is below the horizontal. The bottom of the tower is below the horizontal and hence this angle, say θ2, is the angle of depression. As these concepts are really important, let me quickly throw a couple of examples at you. Say a girl on the first floor is looking at a dog on the ground floor. Can you mark the angle of depression here? Yes, this is the horizontal and this is the line of sight. As it's below the horizontal, this will be the angle of depression. And if she is looking at an eagle flying above her, what will be the angle of elevation? You're right, it'll be this one. Now before moving on to problem solving, let's quickly get one thing sorted out. Till now, for the sake of explanation, we had used this person here. But in many questions, this person will not be mentioned. For instance, if I say that the angle of elevation of the top of the tower from the point on the ground is 30 degrees, then there is no need for you to draw a person here. You can simply draw the line joining top of the tower and the point on the ground. This will be the angle of elevation then. Similarly, if I tell you that the angle of depression of the bottom of the flagpole from this point is 45 degrees, then how will you draw it? You can draw it like this. Now we will solve a few examples. Read and try to understand the question. While solving problems on applications of trigonometry, the first thing that we want is a right triangle. Let us form that from the information given in the question. We are given a lamppost and its shadow formed on the horizontal surface. On the right of this figure, we draw a straight line representing the vertical lamppost and a horizontal line representing its shadow as given in this figure. We are given angle of elevation of the top of this lamppost from this point, which is the tip of the shadow. So if I join these 2 points, this angle will be 45 degrees. We are also given this distance as 20 meters. What are we asked for? We are asked to find the height of the lamppost. That is, we are asked to find this length. Let us name the vertices as A, B and C. So we have our right triangle, right angled at B. The length of the hypotenuse is given and we are asked to find the length of the side opposite to angle C, that is, the length of AB. Can you guess which trigonometric ratios of angle C we can use here? Think of ratios which have opposite and hypotenuse in them. Here we can use either sine or cosec. This is because these 2 ratios consist of opposite side and hypotenuse. Let's solve this using sine here. So sine C is opposite over hypotenuse, that is AB over AC. Substituting the values will give us sine 45 degrees is equal to AB over 20. And do you remember the value of sine 45? Yes, it's 1 over root 2. Therefore, we get the value of AB as 20 over root 2. Can this be our final answer? What's it that we don't like? Yes, we don't really like to see irrational numbers in the denominator. Since there is an irrational number in the denominator, we will rationalize it. How? We multiply both the numerator and the denominator with root 2. This will give us the final answer as 10 root 2. So the height of the lamppost is 10 root 2 meters. You will get the same answer if you use cosec instead of sine. You should try it out yourself. Let's quickly look at one more example in this video. Now I really want you to pause the video and have a good look at this problem. After reading the problem, try to form the right triangle yourself. Here we are given two things, a building and a tower. The height of the tower is given to us as 50 meters and we are asked to find the height of the building. It gets a bit tricky at this point. Maybe you have a doubt now. You must be wondering if the height of the tower is more or less than that of the building. That is, which structure is taller than the other? Is it the building which is taller or is it the tower? Does the angle of elevation tell us anything about the height of these structures? Let us find that out. Let's keep this on hold for a bit. We will use a different example to find the relation between height of the structures and the angle of elevation. Consider a flagpole that we have seen in our previous videos. The angle of elevation of its top from the point on the ground is say theta degrees. Now let's increase the height of our flagpole. What happened to our angle of elevation now? Has it increased or decreased? We clearly see that it's greater. So more the height of the structure, more will be the angle of elevation of its top and vice versa. Back to our problem. Here the angle of elevation of the top of the tower from the foot of the building is 60 degrees and the angle of elevation of the top of the building from the foot of the tower is 30 degrees. So here, since the angle of elevation of the top of the tower is more than the angle of elevation of the top of the building, the tower must have a greater height as compared to the building here. And we are given the height of the tower as 50 meters. We need to find the height of the building. And I want you to find the answer. Only hint I will give you is that there are two right triangles that you will get from this figure. And this side is common to both. Don't forget to share your answers in the comment section below.